So just to tell you the objective of today lab. So the objective of today lab is to practice more timers and counters. We're already done with timers and counters. We learned the basic. So I invite you, if you still feeling not familiar with the basic of timers and counters, to go back to our previous labs in which we were using a bit timers and counters. So here is like a focused lab on timers and counters. It permits you to practice more exercises, to master more the use of timers and counters, to see more applications in the use of timers and counters in an industry base. So that's basically the learning outcome of this lab, is to let you practice more timers and counters. And for this lab, I don't need a submission. So this is, I don't need a submission, but it's really very helpful as a practice for you for your exam. So now imagine you are preparing for the exam. Those kind of questions that we ask in the exam. So yeah, you just go and examine yourself and training yourself on the use of timers and counters. So again, so now I don't need a submission from you because you already submitted to me labs on which you use timers and counters, and I know the basic use. I tested you, I graded you on the basic use of timers and counters. So here is a more practice for you for the exam. Let's consider it as a revision session for the exam, in which you are giving you more exercises and you will practice them. Later on, I'll post solution for this lab. I may record it or directly a PDF, depends. So for example, lab 5, I already posted a recorded video solution because I saw PDF, maybe it's not very helpful. Maybe for this, I directly put a solution as a PDF because I think is enough. Okay, let's go with the first practice exercise that you want to do yourself. It's basically, I started by a simple problem in which I'm giving you the hard relay circuit and I'm giving you the equivalent PLC program circuit. And what I want from you is just able to analyze it and interpret what this program is doing. Okay, so able to understand it and execute it in your logic flow. That's the first exercise. So this is the hardwired relay circuit, and they are telling you motor starts 5 seconds after start button is activated. So when you activated your start button, that's a hardwired relay circuit. You have a time delay contactor. It's energized. That switch will be closed after 5 seconds. That's how this relay operates. So after 5 seconds from pressing the push button, the motor will start. Here is so it will close immediately. Here is it's no timing contact here. It's instantaneous contact. Here is a timing contact, 5 seconds. So this is the equivalent of it in ladder logic diagram. So that's a ladder logic program. You have normally closed, normally open push button. So here they are using internal relay. So they don't need a timing relay. They use a normal internal relay here for a seal in circuit instruction. So that's the seal in circuit instruction. You have it here, here, and here. And after 5 seconds, time base is 1 second, preset time 5 seconds, so then the motor will be activated. Okay, so you will practice it. This is the first exercise. Second exercise now, so I'm not giving you the ladder program, and I ask you to convert it to ladder program. So here, this is a hardwired relay circuit in which warning horn sounds for 10 seconds whenever star button is activated. So they are telling you, but you can try to analyze it yourself. What will happen is when the star button is activated, this horn will sound for 10 seconds and then stop. Each time you go and press the push button, so you will hear the alarm or the horn providing sound, generating sound for 10 seconds. So let's try to analyze it. Okay, this is a hardwired circuit, not the ladder diagram, so you need to draw the ladder diagram. First thing you need to do is to specify your input and output. So this is your input module, this is your output module. So how many input and output you have? Okay, so I can say directly I have start up push button 1 and I have reset push button 2. Do I have anything else? Do I need anything else? I can directly know that I have a horn as an output. Is there anything else? I don't know. So when I press my start push button, I will assure the continuity of electricity in this rank. And this is hardwired again, relay circuit. So then contact relay will be activated. It will activate time delay contactor. It activated, and then here you understand that what time of timer you may use. Maybe you come up with different timer. I don't know. So if you forgot about timers, what type of timers you have and so on, so you need to go back to your basic session or the lecture. Even the lecture, you have it on Moodle, in which we discussed the types of counters, timers. With this exercise too. Exercise 3. So now in exercise 3, yes, that's exercise 3. I'm also same as exercise 2. I'm giving you the hardwired circuit. Just in the first exercise, I give you both circuit, in the sense just helping you starting. So in this exercise, also the same. So you see this type of maybe exam questions. So we ask this kind of question. Okay, so I'm giving you the hardwired relay circuit, and I ask you to find the LAD diagram or to write the LAD program equivalent to this circuit. And this is, I'm telling you, it's automatic sequential motor control system. I have motor 1, motor 2, and motor 3. Motor 1, I call it lube oil pump motor, main drive motor, and I have a feed motor. Okay, 3 type of motor. So first thing, again, when you want to draw you write your program, you want to tell me your input and output. So then at least I can say myself quickly that I have 3 output. Do I have more? I don't know. I can see directly I have 3 input, easily seeing I have PB1 or star push button and stop push button, and this is normally closed and this is normally open, so I should use the same. And I have pressure switch. So this is my program. M1 is energized, is helping us. Okay, M1 is energized when push button 2 is momentarily activated, because it's a push button momentarily activated. Then motor 1 is directly energized. So I don't want to talk about the overload. Overload, we explained it in previous chapters, early chapters. This is, you don't need to include in your program, or if you wish, you can include it here as one input, okay, as I presented to you one time. So this is overload. It's for protection, to protect your motor. Okay. So when you press start, that's what they are telling you. M1 is energized. All right. When the loop oil pump pressure switch closes, when the pressure switch closes, maybe after certain pressure at the atmosphere or in the pipe, etc., this pressure switch will close because you regulate it to close for a certain amount of pressure. When you reach this threshold of pressure, it will close. When it closed, automatically will, that's what they are saying at least, right? M2 and D2 are energized to start M2 directly and begin the TD time delay period. So we'll start the TD here. You have a delay period of 15 seconds. So after this 15 seconds, the feed motor will start. After the time period, TD1 contact closes to energize M3. So you see the program is clear and the hardwired relay circuit. You need to draw the equivalent ladder diagram of it. That's exercise 3. Any question up to here? They are clear, the exercises on timers? Yes, do you have any question or they are fine? Okay. So you need to practice them, guys. Just I'm introducing them to you because we are not at face-to-face lab. So I decided like just I introduce them to you and then I keep the timing for you to work. But usually if we are at a lab, just I give the lab sheet to the students, or even I don't. So I post it on Moodle. Actually, I didn't post it on Moodle yet, so I need to do. I usually post it on Moodle, and they go over them and they ask me question by question. Once they finish question 1, they go and ask me about question 2, and I explain for each team alone. Okay, so I do it this way, so I don't explain prehand. Some students, they feel they don't need explanation. They read it, and in case they have question, they ask me. So it is more likely like that. So they read it themselves. Okay, we need to convert it to ladder diagram. So they do. If they have questions, they ask. So here in this exercise 4, well, what is the exercise here? Here it is, I'm asking you, I'm giving you the program. So you need just to implement it on your Logic Pro and analyze it. Interpret if you wish, or analyze. What this program is doing. Here also in the title they are telling you somehow what's doing, so apply it and check. Program for switching motors off at 5-second intervals. Okay, but I didn't say everything, so I don't want to explain, of course, now. So you will yourself, when you execute it, just the program is done, so you just need to go and execute it at your Logic Pro and try to interpret it to me. Okay, so that's it. Being familiar with use of timer, practice more the use of timer. So exercise 5. Yes, exercise 5. Here, in this exercise, I'm giving you the hardwired circuit and I'm not giving an explanation of it, assuming that you will be able yourself to interpret it now. So I'm not giving an interpretation. So this is hardwired off delay timer relay circuit with both instantaneous and timed contacts. This is instantaneous contact. This instantaneous contact for it when it's energized. Instantaneously, this contact will be activated. So if this will be open and this will close. So then when the limit switch goes closed, instantaneously this green light will be off and the red light will be on. But after 5 seconds, or not after 5 seconds, this is hardwired off delay timer. So this is off delay timer. So you will tell me this is a 5 second off delay timer. So it will tell me what happens for M1 and M2. Okay, yourself you will tell me, of course. This is question 5. Think about. So this is off delay timer with a 5 second. And here your contact is closed. Here it is open. So what happens after 5 seconds for the contact, for the motor 1 and 2? Okay. Exercise 6, I'm giving you a narrative description only. You see, this exercise 6, it's some mechanical, most of them are industrial mechanical applications. Like here in this exercise, I'm just giving you narrative description. So I'm not giving you, as always, like a hardwired relay circuit, or I'm giving you the solution until you interpret it. No, here I'm giving you narrative expression as lab 5. And from the narrative expression, you need to write your program. Fluid pumping process. This is fluid pumping process. You have a full tank here A. Let's say this tank B is empty. And here is a pump. And you have a pipe. And you have 3 pressure sensors. One at the pump, one at this pipe in this side. And in the right side of the pump, you have another pressure switch. So you have pressure switch 1, 2, and 3. And here I'm describing the process. The process involves pumping fluid from tank A to tank B. So we need to pump it from tank A to tank B. Before starting, they are telling us this condition. PS1, the pressure sensor 1 must be closed. When the start button is pushed, so means you are telling us you have start button somewhere, so you need to use start button. The pump starts. Just I want to tell you, just think about it in a real scenario. If you are in a real scenario, you can understand why PS1 must be closed before starting. Because I don't want to turn the pump when the tank is empty. This sensor should feel some pressure, some water pressure or some liquid pressure, etc. So then when it feels this level of pressure, so it's closed. So do I want to pump an empty tank? No. So logically speaking, that's why the pressure sensor must be closed before starting. So in your program now, you need to pay attention about this. It's very important. When you don't want, when I press my start push button and the PS1 is open, I don't want the pump to turn on. So that's what you mean by before starting, PS1 must be closed. So now, if I come and press the start push button and PS1 is open, the pump should not be energized. Otherwise, you may burn your pump because there is no load. There is no so for safety reasons, this should not happen. So in your program, make sure if now the operator come and keep pressing the start push button, keep pressing, the pump will not turn because PS1 is on. Only when PS1 is closed, so it means when the operator come and press the push button, start push button, the pump will turn on. They are telling you PS2 and PS3 must be closed 5 seconds after the pump starts. So you need to use a timer somehow. If not, in 5 seconds from when the pump starts, 5 seconds after, PS2 and PS3 must be closed. What it means, like in 5 seconds, the fluid should pass from A to B. and therefore the pressure sensor at the pump, inside the pump or at the pump or in the next side of the tube of the pipe should be closed. In 5 seconds the water or the liquid should go to the other side. If either PS2 or PS3 opens, if one of them is open, means there is some faulty thing in your system. 5 seconds passed and then still one of the sensor open. Then in that case directly the pump will shut off. Your pump should shut off. Okay, it's a challenging program, but it's really nice to do. The pump will shut off if after 5 seconds one of them is still open, and will not be able to start again for another 14 seconds. The pump will shut off. The operator will note like after 5 seconds the pump is off, so he will go and he turn it on. It doesn't turn. He keep turning it on. It doesn't turn until 14 seconds passed. Then when he start pressing it, it may turn. It will turn. So basically this is in a real scenario why we do if I have faulty and it shut down, I give some time for checking to see what's wrong, maybe I can put it in a real scenario more than 14 seconds is up to the programmer. But here, so you will have hands-on on how to do this type of program. Okay. Any question regarding this industrial application? Exercise 6. Just to clear the question itself. Anyway, this is a narrative expression. I tried to just connect it a bit with a real scenario for you. Good. Okay. So exercise. So here is an empty space for anyway. Exercise 7 is a bearing lubrication program. You know, like bearing are okay. So the bearing usually are systems that the roller for them are rotating, assuming this type of bearing, or you have a shaft here and is rotating, and therefore you need to lubricate them, especially for a huge system. If you have a huge shaft, you have a lot of heat, lot of friction, and therefore lubrication it's a vital part of the system. And therefore here is a program, bearing lubrication program. What I want from you in this exercise 7 is to analyze or interpret the program. Okay. So I don't want to go over it. You will do yourself. You want to interpret the problem for me. So I can tell you, you have 2 input and you have 3 output. Pump, most probably the pump for lubrication. Motor, most probably that's the motor that's connected to the shaft. And you have a pilot light, which is an indicator for something. So you will tell me it's an indicator of what. And you will tell me the motor starting time delay, pump off time delay, pump running time, etc. So you will tell me about it. Okay. So you need to run it in Logic Pro, execute it, and interpret it. Tell me what did you find. That's exercise 7. So now we'll talk about cascading timers. So this is a program in which you have 2 timers. The program of 2 or more timers together is called cascading. Maybe you put more than 1 timers together, and this is because maybe sometimes you exceed the maximum timing you can put for each timer. For each timer you have a limit because it's a memory limitation in the memory size. Assuming it's a word timing, or it's a double float, number, so then it has a limitation. Otherwise, the memory will be full, oversized memory. So you cannot go over certain amount of time. So then a way to do is to do cascade timer. The programming of two or more timers together called cascading. This is a hardwired sequential time delay motor starting circuit. You have start push button, stop push button, or stop star. When you press it, your motor 1 is energized, so you analyze it yourself and you seal in circuit. Well, in PLC, this we call it seal in circuit. When you do your ladder diagram, this is the latch, we call it seal in circuit. You have time delay 1 and 2. You have two timers here, two time contactor. You need to convert it to the equivalent ladder diagram now. TD1, so after 1 second will close, so it will energize motor 2 and TD2, and then TD2 after 20 seconds it will operate. So it means at the end M3 will operate after 40 seconds. Motors are started automatically in sequence with a 20-second time delay between each. So this is started now. After 20 seconds, the second one will start. So we have a time delay of 20 seconds in between. Exercise 8 is very important question. Exercise 8 is very important question. And this is a question, so I'm giving you the solution. I'm telling you the solution you need to remember always. When I ask you to have a flasher, that's the way you do flasher. And you say to your flasher alarm program. So I'm giving you the program, so you need to go and apply it in Logic Pro and interpret it to me. So understand that how it works and remember it in mind how this system works. The two timers form an oscillator circuit on off. These two timers form an oscillator circuit which generates a timed pulsed output. Here it's a 1 second timed pulsed. So each 1 second those output will go on and off, depends on the switches. So assuming all the switches are on. Okay, assuming all the switches are on. So what will happen is you will see the green, red and yellow, they will go on, off together. Each 1 second, one off, on, off, on, off, on. It's a flasher alarm if you wish. So if you don't have this, only you have, if this doesn't exist, your system is like this, so you have a flasher. Even if you don't have this, you just have the green light, you will see this green light, it will go on and off. So this is flasher. And that's the program that you need to remember always when we ask for flasher. And this will be used as part of later on when you program a traffic light, for example. Traffic light, it contains a flasher. And a lot of applications require flasher, like maybe in your car, you have flasher in your car, in your automobile, etc. So this is the way you program it. As you in programming, you know the two loops for to loop 4 together, etc. So this is something we always, as programmer, we remember it. Okay, so you need to execute the code in this exercise 8 and interpret it to me. Okay. Keeping in timer, I think they are, still have few. We will finish them and I stop here. You will tell me if you want me to introduce counters or not later on. But let me just finish the remaining 2 or 3 exercises still. This is exercise 9. So exercise 9 is switch. sorry, it's a cascading of timers for longer time delays. That's what I was talking about in a while, but I just get confused in between it and the previous exercise. So cascading a timers for longer time delay. So if you want to have longer time delay, maybe this is the way you cascade them. So you put the output of the first as the input instruction for the second, and therefore the pilot light will go on after 30 second plus 12 second. Okay, so after some times it will go on. So that's how we cascade for longer time delay. If assuming this is the maximum time you can have and you need more, so you cascade them to have more time. So then you understand it. Just you need to apply it and understand it. Okay. So interpretation exercise if you wish. Okay, this exercise 9. That's exercise 10. So you see in exercise 10, I'm giving you the solution. But you need to execute it in your Logic Pro and interpret it to me. Show me what you obtained. Okay, understand the program. Please don't do it as blind eyes. No, understand the program. This program for traffic light in one direction. So you need to tell me what's happening, the timing delay. If you feel the timing delay is too long, you can in your program, if you don't want to wait too much for 30 seconds, 25 seconds, you don't want to wait as you are feeling as in you are waiting in a traffic light, it's all right. You can reduce the timing, okay? No, nobody will tell you don't reduce it. It's not a real traffic light. So don't want to wait for long timing. It's all right. So change the timing. This is one direction traffic light. And exercise 11 and the last exercise is two direction traffic light. So that's it for the timer. As I said at the beginning, I don't want a submission for this exercise, for the timing application. I mean, you see, it's very interesting. You have a lot of industrial application like lubrication, bearing, tank process, traffic light. Okay, so you have a lot of interesting application in industry, flasher, but considering as more practice for you, like more practice for your exam in the use of timers, more practice for you to gain more experience in timers. That's it. I don't need submission. I'll put a bonus submission. Okay, I'll put on Moodle bonus submission. So for those who would like to do, they do. For example, actually I get impressed by mechanical student, Haider. Haider is mechanical student, and he did the bonus. He was the only one who submitted the bonus for the PID. So which is really nice. I encourage you to keep doing it. And he did the analog scaling correctly. Maybe only few did the analog scaling correctly. So I posted his solution on Moodle. So I encourage you to do the bonus, because this will really improve your grade at the end. But it's optional. Okay, the bonus is optional. This is bonus. Timers, I already graded you on previous lab submission on timers. You used already timers. Okay, so I don't want to grade you more, but these are for more practice for you. Some maybe more challenging exercises. The one we did previously in the lecture, or when we explained timer, or in the lab when we used timer, was the basic use of timers. We used it maybe in arithmetic operation and etc. to on off something. So basic operation. So means you understand how timers it works. So here is more challenging exercises and more industrial context. Okay, so I encourage you to do, but they are not required. What it is required from you is the basic. For your exam, of course, the exercises will be as this exercises. So then those are extra practice for you. The definition of this lab is extra practice on timers. Extra. So you can do if you want to practice more. As in any programming language, you more you program, you more feel yourself more confident in the exam or in your work later on if you work on that field. So I encourage you to practice. You have the time today, and no submission is required. Any question regarding timers?